Hello everyone, welcome back to Practical Serverless and Microservices with C Sharp. My name is Mohammadullah and I'm Microsoft Azure Solution Architect. And for this course, this is my agenda. So first we will understand the how serverless application work. Then we will look the microservices, then on your architecture, then how to work with Docker. We will understand different type of Azure function, their types like trigger, background functions, IoT function, and microservices, how to organize microservices with Kubernetes. Then we will see the containerization in microservices with help of Kubernetes and Azure Container App. Then we will check the security observability inside serverless microservices. And in the whole this course, we will consider one car sharing app. So we will see this in action. And lastly, we will understand how .NET Spire work. So if you missed the other session like 1 to 3, so please check out the first, second, and third, then continue the for this session. And yeah, I will share the link of the playlist in the description of this video. So in this session number 4, we will understand the onion architecture. First, we will see some of the theory. After that, I will show you this in practice. Then I create one template and I will show each part in the template. And I will also share the template link in the video description. So what is onion architecture? So there is one principle like the onion architecture software design. First of all, this is a software design pattern that organize the code in layers. So onion architecture have different layers, but the key principle is the dependency direction. So like the outer layer can reference inner layer, but the inner layer does not have reference to the outer layer. So this is the key principle of the onion architecture. So this is the basic diagram. We have the first layer, the infrastructure layer. Then in the middle, we have application specific code. So infrastructure, we have databases, file, cloud services. So this is the basic version of the onion architecture. So the core concept, you will think like a onion. The innermost layer contain your core business logic, but what your application actually do, it's in the inner layer. While the outer layer handle technical concern like database, web APIs, web interfaces, and the external system. So this is the core concept of the uh, onion architecture. So in onion architecture, we have, as we mentioned in the slide, we have some like different type of layers. So outermost layer is called the infrastructure layer. It contains all the technical drivers like database connections, web frameworks, UI components, and it handle the dependency injection and reference all the inner layer, but never referenced by them. So this is the outermost. We will see this in diagram as well as in code as well. So second, we have if we go check this is the complete onion architecture. As you said, as I mentioned that in the outermost layer we have infrastructure. Infrastructure have databases, files, cloud services, and web APIs. So this is the first layer, the infrastructure layer, handle dependency injection, reference all the inner layers, but never referenced by other. So second, we have application layer. Define what operation your application can perform. So in this layer, we have all the use cases, all the like command handler queries inside this layer. Like it contains use cases, application specific workflows, and it have only referenced by the domain layer. So this is the second layer. We have application layer, and this is the heart of the onion architecture, like the domain layer, which is also called the core layer. It contains all the business entities and rule, and it's the heart of the application. Like what application fundamentally do, it's inside the domain layer, and it has no dependency on other. So we will see this in action. It has no reference by other project. And or domain layer sometimes like split into model like entities and domain services. We will see this in action. Like we will cover this course with respect to domain driven design. So in domain driven design, we have entities, aggregate, root aggregate. We will see this in practice. So this is the complete diagram of the onion architecture. First, we have the infrastructure, and then we have application services, and then we have a domain layer. So infrastructure have database, web APIs, and other UI component, and application services have all the use cases, what the application can actually perform, and the heart of the application domain layer, all the business rules and models is inside in the domain layer. So this is the complete onion architecture. Okay, as you can see that this is the onion architecture template. So as you can see here, we have basically four layer. The first one, we will go one by one. So first we'll discuss the infrastructure layers. So infrastructure layer, we have a DB driver. So there is one C# class library that contain the database related things, and we can also call the web API layer as an infrastructure layer. So these two layer, web API and DB driver, is the part of the infrastructure. The DB driver handle the DB connection. You can see here, this is DB context. It has all the required model and all the migration related things. And if we go to the repository, it has all the repository implementation. Like in this template, I am considering the car booking application. So it has booking repository, car repository, and and user repositories. So also we have extension to connect this model to others. So we have this extension. We will call this in like a program.cs, the main dependency injection. So this is the infrastructure layer. And second, if I go back to the, you can see here. The first layer infrastructure, then we have application layer. So if you go back to the code, you can say here application layer. This is the application layer. And first I will also show you the references. So the key principle of the onion architecture. This is the infrastructure layer, and it has only reference of the domain layer, so nothing else. uh, Command handlers, like it will create booking, it will create car, create user. So this is like the command handlers use cases. You can see if I open, so this will create a booking for us. So this is one of the use case. And in this folder, the command folder, we created the command like if you are going to create a booking, so this will be the command. This is like a request. Okay, first we will pass the user ID, car ID, start time, and end time. So this is like the command for this command handler. Um, you can see here I'm passing it the I request handler. So this is the command we created in the command folder. So next we have events. Some like inside microservices are domain driven design. Entity, so when any entity change, and when any change happen in entity, so it will create some event. So when booking happens, this event will be will be raised. So we will see this in like a detail in the domain driven design. We have extension like a data dependency injection handler, and this is a service collection to connect with other part of the application. And then we have queries. So we have in the CQRS we have some command and queries. So for this we get all the available cards. We have this query to get user booking. So we define all the queries here. So this is my main point is to show you the application layer. It has all the use cases. The domain layer. The domain layer have like all the domain entities, all the business logic. So this is a model, booking model, for example. This is the booking model. Username car, and this is the all information needed for the car. This is user. So we have all the core model inside this domain layer. So let's come back to the slides. Okay, so I practically show you how the domain will get look like. Like first we have the infrastructure, then we have application, then we have the domain layer. So the dependency is going inward towards the domain layer. The domain layer will be independent. It will not contain any reference. The application service will have reference only to the domain layer, and the infrastructure layer have only reference the application layer, not the domain layer. So this is the uh, dependency principle for the onion architecture. Now, next we will cover the domain layer of the Onion architecture. So, core concept is contain domain entities like classes with behavior encoded with public methods, and entity can only be defined through the method presenting actual domain operation. You can think like as a domain-driven design. We will focus mainly on the domain-driven design. So, it also use a unambiguous language, and the business team will follow the same language. So, this it's called unambiguous language. Okay, so then we have the domain layer. Domain entities. We have state. State all can only be changed through the method that encoded actual domain operation. And we have aggregate. Aggregate must be completely covered from the persistence code. And we have like each domain layer have one repository interface as well. And in the domain layer, we have like one is called the domain entity, and we other have the core EF core, yeah, entity framework core entity. Domain entities have method enforce business rule, and tree of nested object like aggregate. Aggregate is the group of related object. It's called the aggregate in a domain driven design. And uh, EF core entity just have a property value pair with no methods, and it have only save data inside the database. So there is some difference between these two. Okay, so please understand this. Domain entity have method in for business rule, and it also have the aggregate like a group of related entities. And but the entity framework core entities just property value pair. And then we have aggregate. What is aggregate? Complex tree of object related order. For example, if we have order, and the other object is purchase order. One is called purchase order, and the other one is purchase order item. So this is the example of the aggregate. So we will also check the aggregate root as well. For example, if we have purchase order, and one is purchase order item. So order item cannot exist without the purchase item. So here the aggregate root is purchase order. And child object cannot exist independently, like purchase order item cannot exist without purchase item. So manipulate it as a single unit. So we can treat this as a single unit, also called it aggregate. So here is the example of the aggregate. We have purchase order where we have order items. Okay, and the only thing that can change or manipulate the purchase order item is the purchase order. We cannot access purchase order item outside the purchase order. So this is the rule of the aggregate in domain-driven design. So you can see here in this purchase order, we can add, we can remove item to the purchase order item list. So this is the rule of the aggregate inside domain-driven design. Then there is one another concept inside domain-driven design is the value object. It object with no identity. So in identity, in domain identities, we have one unique identifier. So each record can be identified uniquely. But in case of value object, we have no ID. There is no identity inside this object. Like for example, if we have address, in address we have phase number, street number, house number. So these three create the value object related to the address. Same for the money as well. And it's mutable. Once it's created, cannot be changed. And implemented as C sharp also provide the record, so we can implement this as a record inside when we do actual coding. And there is no repository needed for a repository interface needed for value object. So here is the example of the value object in domain-driven design. For example, if we have address like country, town, street, so combined we create one record which is called the value object. So next we'll cover the repository pattern. Like since aggregate and value object differ from ORM entity. Like ORM actually save the data inside the database, but aggregate and value objects are different. We checked in the previous slides. When using ORM to interact with database, you must translate ORM entity into aggregate and value object and vice versa. Each time exchange data with ORM. Through the ORM, we exchange data from the ORM entity to the aggregate and value object, and aggregate and value object to the ORM. So in this case, the domain layer interact with actual ORM implementation through the interfaces. So in this case, we need the repository pattern. So this is the core concept why we need the repository pattern in the domain-driven design. So this is the reason. And there is one rule, each aggregate root. I already said that aggregate root, main entity in a group of related entity. Like in aggregate, we have related entities, and there is one key entity which is called the aggregate root. All the child entity aggregate depend on the aggregate root. Should have its own repository interface. Aggregate root, one repository interface. This is the rule, and the repository work with the whole aggregate, not with the individual entity. So this is another rule. This keep your code clean. What is the purpose? Keep the code clean, modular, and align with DDD, domain-driven design. So we will follow the domain-driven design principle. So that's why we need this repository pattern. We must follow this repository pattern rule. Example of this repository pattern is purchase order. For example, in previous slide, we see this is a purchase order. This is one aggregate. And what is the root aggregate? Purchase order is the root aggregate. And what is the uh, child entity? Purchase order item is the child entity. So this aggregate, it will need one repository. And here is the rule. This is the example of the repository. Okay. And we have new get async, delete async, delete async with the purchase order, and get release. So this is all the functionality it will provide. So it will need the interface. So next we have a domain services layer. In complex application, it's best practice to split the domain layer into model layer and domain service layer. Okay. So domain layer contain only aggregate like entities and value object. Entity have unique identity, and value object without key. So this is key difference. And the domain service layer. What is the purpose of domain service layer? Contain repository interface and domain operation that does not belong inside a aggregate. So contain repository interfaces and the domain operation that does not belong inside aggregate. So this is each like model have domain layer have domain service layer as well. So domain service layer have the repository work only with aggregate like order customer, and but sometimes you do not want to the whole aggregate. You just need a read model like get data from any database. The domain service, you want to show a dashboard. For example, if you want to show dashboard with customer name, order total order, and last order date. So this is the requirement. So this will not come from the single aggregate, but it will come from like customer and order. So here we will use the domain service that will interact with different domain or different entities like customer and order. Now we will go deeper into the application service. It's a layer above the domain layer. So you can see here, this is our application layer. So it's have only one reference domain layer. So it's the layer above the domain layer. So the second layer, application layer. We will discuss this in detail. It does contain domain rule itself. For example, order cannot be less than zero. Something like when we add item to the cart, or when we place order must be greater. This is one of the simple business rule domain rules, and not live in the aggregate and domain service. But it accept command, it accept what is the accept command and query. The accept command and query. You can see here it have the command and the queries. call the right repository or query service. Publish domain event is something important. We can see here these are events. So when booking are created, we will raise this event. So application service also raise the domain events as well. Okay, we have a command operation, query operation, command modify aggregate through repository. Aggregate to repository can raise domain event as well, like place order event. And query use query service, it return DTOs tuple, and, no domain events, just return data. So this is about the application layer. And when you go to the query, it does not have the event, no domain events, just return the data. But this, like we have create event handler command. When booking is created, this event will be generated. You can see here when we create the booking. So when we create the booking at the last point, publish domain event. So this is called publishing domain event. Command raise the domain events. So this is I explained this in the code. Application service operation in the application service layer are split into two types, like queries command already discussed. Command execution can trigger events. Also application service must also handle domain events, already explained. And we have queries. This is the some deeper look of the queries. A query object represents one or several similar queries usually have one or several method that take input and return queries. Query result. If we go to the query, for example, get available car query. So it will take this query. We are only passing the location. This is the query, and this is the query handler. Most query method call a single repository method implementing the needed query to some may execute several repositories. So a query can also get data from single repository. It also can get data from multiple repositories as well. Next, we have query testing. During system testing, actual query implementation are placed by fake implementation. So each query has a associated interface coupled with the actual implementation in the dependency engine. This enables the UI to require only the interface to infrastructure. Allow testing with fake implementation. If we don't use the interfaces here, so the system will be unable to test. So to test that, we must, like you can see here, this query is inherit from the I request handler. If we don't do this, like inherit from the any I request handler, the system cannot be testable. So to make the system testable is most important thing. So we must follow this testing principle. So like this is the example, we have one query that contain that will return the basic information BTO, and it will take the start. And you can see here we are inheriting this purchase order by started from the I purchase order by started query. So this is important thing, and I purchase order by started query is inheriting from the I query interface. So I query interface is necessary for to make this system testable. Next we have command. We will see the command in the detail. Command work differently because each command represent a single application operation for better code readability. Like command, we follow the single repository principle. Like each command will have only single operation. So each a unit of work, like a unit of what is a unit of work in a DDD or CQR, plus CQRS. We are following domain-driven design and CQRS. In the DDD and CQRS, each command load aggregate via repository, call method on them to apply changes, command apply changes, and then we have save changes. So first we load, then call the method to apply the changes, then we have another save changes in database. But in reality, you may touch multiple aggregate in a single command. Uh, you want them all to save or roll back together. Like for the transaction, if we deal with multiple command, so to make this atomic transaction, this we will use the unit of work. The job of the unit of work to make all the repository operation to make it in a single transaction. If I go back to the here to the code, you can see here I have a unit of work. So it will make the atomic transaction. To make the transaction atomic, we use the I unit of work. We save entities. We have start async, commit async, and rollback async. So example have unit of work example. Save, start async, commit async, and rollback. So unit of work breakdown. We have save entity async, save all the update in a single transaction, return true if storage actually change, otherwise false. And start we use to start the transaction, commit and rollback, respectively commit or rollback and open transaction. So this is needed to make the data consistent. Okay, so unit of work, transaction control method are useful for this is the save, start, commit, and rollback. So this method transaction control method are useful for in closing, get operation, and final save entity async save in the same transaction. So example of this is we start the transaction, we get all the flight async. If like there is no seat, we roll back. If the seat is less than zero, we roll back the system. Otherwise, we commit. Okay, next is the domain events. For example, let's go back to the code. Uh, Let's go back to the code. You can see here when booking is created, this is raised. The booking create event is raised. So this is called domain event. This is called domain event. Raised inside the same microservice when something happened to aggregate. When something changed in the aggregate, the command raise the domain event. For example, order placed event. In our example, booking created event. When a new record is created, handle inside the same microservices. So it will be inside the microservices boundary, and it follow the publisher subscriber pattern. So for example, this is the publisher, and where is the subscriber? It will be inside the handler. So this is the actual event handler. So whenever anyone subscribe, it will subscribe to this one, and it will be notified to the event notification. Okay, there is two things, like one is the domain and the other one the integration event. So anything happen inside the microservice, it is called domain event. But if one microservice can communicate with other microservice, then we use the integration event. REST to communicate across the microservices. Example, order place integration event. Send to a payment microservices or notification microservice. So here two microservices are communicating to the integration event. So this is two type, like one is domain and the other one is the integration event. Oh, so why we use the event like inside microservices boundary? So why this important? Aggregate raise event about important state change. Instead of writing side effect inside aggregate, we capture the event. We capture the event. This event can collect it, and then the command handler publish them before calling unit of work. These ensure that events are only published if the transaction succeeded. So if we go to the code here, you can see here we publish the event after making changes to the card repository. Then we raise the event. So this ensures the event are only published if the transaction succeeded. Otherwise, we will not. So we will also take help of the unit of work, save changes async as well. That's why we define events inside the microservices boundaries. So this is the structure of the event. We have interface, and then we have a handler. If I go back to this is the publishing event code, and go inside. This is a domain event, and this is a definition of the event. And we are inheriting from the iNotification handler. So this is the example iNotification event, and associated each event with all its handler. So here is the example how to associate event with all its handler. So we have event triggers, and inside that we have one structure, then we have one trigger. We will learn how domain object work with database, because the business logic of the domain should not know about the databases, because if they do, they will violate the user. It will use the infrastructure layer, so this is not recommended. So database store data in table and rows, and the business object like aggregate work differently than the database table. Like we cannot pass domain object directly to the entity framework. Entity framework model is different than the aggregates or a business domain, and EF core does not track or domain objects. So this is one of the problem. So how we will fix this problem? So there is one solution called a state object pattern. State object pattern. So the core idea of the state object pattern is that it separates the state from the behavior. So state mean like data, like object has some data, and the behavior mean the logic. So with the help of state object pattern, we separate the state and behavior. So how we'll do this, we will see in the next slides. So first of all, for example, first step, we create the state interface where we define all the properties like creation date, delivery time, and list of item. For example, if we use the purchase order state. So this is the first step. The second step will be business object use this interface. So we will pass this state interface inside the constructor. We will use the aggregate constructor, and we will pass that state with the help of constructor. And then we will save this state inside private variable, a private state variable. As you can see in this example, we have one private variable. I purchased order state, and I am passing the state inside the constructor, and we are saving the state inside the private state variable. So this is the second step. And the third time step, you will modify the entity, like database entity. You will inherit it from the interface purchase state. So as you can see here, in the first step, we created the state interface, and we are inheriting the database entity from that state interface. So this is the last step. So how I will show you this in the code. Like if I go to the code, so you can see here, I modified the code to fulfill the requirement of the state pattern. Okay, so you can see here now this is the aggregate, and I created one state interface called iCar state. You can say if I go to this, you can see here this is all the properties needed for this aggregate. And this is the first step. And second, we are the aggregate is we are passing this state interface using this aggregate constructor, and we are saving the state inside this private variable. So this is the example of the state object pattern. And you can see here we have in this class we have behaviors, and we have behaviors, and the state is located in this state interface. And the second part, this is the database model. We are inheriting this from the istate call. So this is the last step. So you will follow this pattern to make this like state object, to follow the state object pattern. So that's this in this way we can communicate with database. And so this is the example of the state object pattern. So here is the so this is the life cycle of the aggregate life cycle. So first, for example, we need some customer data. So we'll use the repository interface. It will get all the data from the repository using the DB driver, and the DB driver will contact with the ORM. ORM will map the data, and it will get the data from the database. So this is the first flow. It will get the data. So you can see here from the right side, the database will provide you the tuple, and then the ORM will start tracking that entity. ORM will start tracking the entity, and the constructor aggregate will accept the state of the uh, state of the entity by using the aggregate constructor, and it will create new aggregate. You can see here in the dashed line, the aggregate is communicated accepting the state through the aggregate constructor. So once aggregate receive the state, then we will make changes to the data. Then unit of work, in the last flow, you can see here from the left to right, we have unit of work. After making changes, we will call the save entities, and implementation of unit of work will pass that changes to the ORM engine. Basically, the ORM engine will follow the tracking. So the magic here is the tracking. So you can see here the dashed arrows. It will track all the changes, and it will update the data inside our database. So this is how the state object pattern work. Okay, so this is the last topic. So I hope you will find this helpful. If you have any question, you can ask. And if you are new to this channel, please subscribe and like this.